Hey, welcome back to Math with Patrick. Today is September 5th, and we're solving problem number 248 from the Daily Epsilon calendar. And like with the other problems in this calendar, the answer is supposed to match today's date, so we should expect a 5 for our answer. So as we're finding the digit O, we should expect to see a 5 at the end of the problem. So I see like a 2-digit by 2-digit multiplication problem here, where once we kind of do the multiplication and we add these numbers together, we're going to get another 3-digit number. So, I mean, if we're looking for O, maybe the first thing I'll look at is this. Let's just kind of write a random like multiplication problem here. I am choosing different digits for the tens place, and then I'm choosing the same digit for the ones place to match the problem. But if I try this multiplication, 2 times 2 is 4, and that's not the same digit as 2. So as I look for the digit O, it could be 0, 1, 2, all the way up to 9. I could kind of quickly cross out some candidate numbers, or I guess the non-candidate numbers if I'm crossing them out, just based on this first observation that I saw, that this O times O should result in another O in the ones place. So 0 and 1 could both work, because if these were both zeros, then I would get a 0 there. Same thing with 1. If they were both 1s, I'd also get a 1 here. But 2 doesn't work. And 3 doesn't work because I get a 9 in the ones place. 4 doesn't work because I get a 6 for 16. 5 does work because I get 25, so that's good because the answer is supposed to be 5. Then 6 also works because 6 times 6 is 36. And then 7, 8, and 9 all don't because it's 49, 80, or 64, and then 81. So just looking right here at the ones digits, I can already kind of rule out over half of the candidate numbers for O. And just to kind of understand what's going on a bit more, I'm just going to run through this multiplication, and let's pick say 0, right? Because we know that 0 is a potential candidate number. Let's just see what happens if we try putting a 0 there, and I'll put just 2 other numbers right there. I mean, I know that this is going to be 1200 just by like multiplying these and tacking on the zeros, but I do want to fit the same format as this problem to learn more about it. So 0 times 0 is 0. Great. 0 times 3 is 0. Oh, so that would mean that this would need to be another O. Okay, I mean, that rules out 0 immediately because I would need another O digit right there. So we can cross that out and try with ones instead and see what things show up, see what similarities we have with this over here, and maybe we can find some kind of contradiction by trying this one. 1 times 1 is 1, so that still satisfies those ones places. 1 times 3 is 3, and so far so good, right? Because this G and this G match. Oh, but then at this point, I would put my little like placeholder, like I'd put a 0 here, but since it's blank, I'll just leave a little blank spot. But at this point, I'll be multiplying these numbers, and I don't have a 100s place here. So I think that rules out 1 being a possibility, because even if I have a bigger number right here, I would just have that same digit right there instead. And there's no way for me to get a 100s place if I have O being the digit 1. So now we are on to the 5, and hopefully we can find some kind of answer here. Another thing that I just noticed, though, is when I did G times T, that number went there, right? The 3 times the 4 got a 12. And in the original problem, G times T is just giving me G and no like thousands place essentially. So that tells me that either one of them is 1, I think. Because it's the same, I don't know, it's a similar idea as before when you try to like try some numbers, multiply, see what works out there. either that both the numbers need to be small, right? Because like 2 times 3 would give me a 6. That is just one digit, but it's a different digit. So in that case, I think that means that t has to be 1, because then g copies itself here. So let me slot in a 1 right there. I still don't know what g is supposed to be. We at least know it's supposed to match here and here. So let's just try some stuff out. The first number that makes sense for me to try is a 2, because it's not supposed to be a 1. Let's just see what this multiplication says. 5 times 5 is 25, so we're going to put the 5 down here and carry the 2. Then we're going to do 5 times 2, add on the 2, and that's a 12. And so far, this is looking good, right? The 2 matches where the g's are, and then the 1 matches where the t's are. So that's nice, I guess. Little placeholder spot. This 1 is going to multiply by the 2 and the 5. And so that makes sense that the whole number here is going to be kind of repeated because t is 1. And then adding these up, clearly this 5 just drops down. That matches with the digit O. G plus O is R, so it looks like R is supposed to be 7. And I guess the whole point is just to say that these 2 digits are distinct, and R is also distinct from anything that came before it. So fortunately, I don't have any 7s up here. And then 1 plus 2 is 3. And then 3 also has that same idea where it's different from all the other digits, and we haven't seen it before. But this seems to work out. So I guess that's our answer. This kind of matches the problem statement, and O is 5. So I guess we're done. Although, I feel like I want to rule out all the other possibilities. So if you'd like to, you can stick around because I'll keep trying stuff. Because, G very well could have just been a 3. As far as I know. Maybe we can, rule that out together, that G can't be a 5. So T is definitely 1. And we're currently testing out O being a 5. And just let's see what happens if G is 3. So this is still a 25. And then 3 times 5 plus the 2 is 17. And then got it. So this G is no longer matching this 7. So it looks like this number right here is always going to be 2 plus and then 5 times G. And according to the problem here, these digits need to match. So I could just try again with the number 4, but that's going to be the number 22. Let me just put my ideas on a table just so I can see it. So the 3 gave us a 17, and those 1's digits don't match. The 4 would give us a 22, and basically I'm just adding 5 every time, because then once we plug into 5, it'll be 5 times 5 plus the 2 is 27. And so on the right-hand side here, these are just going to alternate from 2 and 7, 2 and 7. So really the only other number that might work here is if we get a 7 right here, because then we would have a 1's digit place match of a 7 and a 7. So maybe that means I could place a 7 right here. And let's just run through that multiplication again just to make sure. This is still a 25. And then this is that 37 that I was talking about. And, but then these don't match. Okay, cool. And T had to be 1. And this number is a 3 now because the 7 is bigger. So I did need a small number, namely the 2 that matches with the 12 here, in order to create a 1 in the hundreds place. So that rules out, let's just double check. Oh yeah, because 8 and then 9 aren't going to match the 1's place of either a 2 or a 7 right here. So that tells me that if O is 5, which it is, this is the only example that's going to work. Though we didn't touch 6s yet, and I'm still curious. I still, there's potentially an answer out there. I want to rule them all out. So we could place a 6 here and a 6 here. T, again, has to be 1. And then I guess we could play the same game and try to see what G is going to be. I think clearly the first number to pick is a 2. This is a 36. And then 6 times 2 plus 3 is 15. And then the g's don't match. And then if I incremented this up to a 3, that would be 18 plus the 3, which is 21. And then now this 2 right here would not match with that 1 right there. And it would always be bigger, 2 or bigger, if I try other numbers for g. Okay, I think that about settles it. So I think I'm all good. I think I checked all the numbers, covered my bases, and we can be very sure that this multiplication right here is the one and only 2-digit by 2-digit multiplication that kind of shakes out this way with the digits. So we're all done. Thanks for watching. I'll see you tomorrow.